There was a small village with a very few houses. Where the nuclear power plant is, there used to be 1 or 2 small houses. How far from our house is the nuclear power plant? 800 meters, not more than a kilometer. I'm local. My father and grandfather were born here. Once, some guests arrived and wanted to find their father's birthplace, but we could hardly find it. Construction of Ignalina nuclear power plant started in the late 1970s. The first unit was commissioned on the 31st of December 1983. At that time, the construction of Unit 2 was underway, and over 13,000 people were working on the construction site. Visaginas is the youngest town in Lithuania. Just 3 generations have lived there since the town was founded.
На момент ввода в эксплуатацию блоков Игналинской атомной электростанции
When Ignalina power plant was launched, electrical power capacity was 1,500 megawatts. These were the most powerful reactors in the world. We used to produce 60 to 90% of the total electricity needs of Lithuania. Our only rival in this regard was France. We were the strongest in nuclear energy among all European countries. Electricity was sold at about 7 centas per kilowatt hour. 5,000 workers were employed in the Ignalina power plant. And about 30,000 residents lived in the town, Sniečkus.
5000 человек, а в городе Сничкус жило 30 000 человек.
When Lithuania gained independence, the town of Sniečkus was renamed Visaginas. The control and maintenance of the nuclear power plant were successfully transferred to the Lithuanian government. Scientist Jurgis Vilimas dedicated most of his life to nuclear energy. He saw the Ignalina power plant being built, operated, and shut down. It was a unique site, and from today's perspective, we can state for sure that it was well built and well operated at a high technological level. Our environment is clean. We constantly take samples and see the results. We don't need to go to the market, as we grow everything here by ourselves. We love picking mushrooms or fishing. Everything that grows in the vicinity can be found on our dinner tables. After the Chernobyl disaster, the nuclear RBMK reactors started frightening Europe. The decision to shut down was taken despite all the preventative measures that had been implemented in the Ignalina nuclear power plant. The Western leaders were adamant, and in July 1992, the G7 Munich summit adopted the general provisions on the safety of the nuclear power plants in the post-Soviet region.
Многими проверками Международного агентства
The International Atomic Energy Agency and the World Association of Nuclear Operators conducted numerous tests and assessed that Ignalina nuclear power plant meets the standards of the highest safety and reliability. The main force for the shutdown was political, not technological. The political attitude was largely shaped by the psychological fears after the Chernobyl accident. There were no severe accidents during the entire Ignalina nuclear power plant operation period. From the very beginning, Ignalina nuclear power plant has been conducting environmental impact assessments, consisting of many observation points and a modern laboratory. Water, air, plants, and mushrooms are tested up to this day. I have been working in the nuclear power plant since 1995. We worked safely, and I never even had a thought about the plant shutdown. But that's the way it is. We will see what will happen next. More than 30 countries worldwide are developing nuclear energy. Almost 450 reactors are in operation. All countries have to start accumulating funds for the plant decommissioning from the beginning of its operation. Unfortunately, such a fund was established at Ignalina nuclear power plant only after the restoration of independence. Therefore, the situation with the power plant shutdown was complicated. It was admitted that decommissioning is too big a financial burden for Lithuania, whilst European countries wanted to shut down the power plant as quickly as possible. The anticipated date was 2000. It was agreed that the first unit would remain in operation until the replacement date of the technological channels. The designated lifetime of the technological channels was 15 years. However, the personnel of the plant and scientists managed to prove that the fuel channels of the first unit could serve longer than until 1998. The operational time was therefore extended by an additional 6 years. We had a hope that the second unit would be kept in operation for longer. However, the Western position was strict, and the maximum extension that could be negotiated was the last day of the year 2009. This is what was done.
Tas ir buvo padaryta.
Decommissioning works began that were unique in the history of the world. It is a great opportunity to use the accumulated know-how for other nuclear power plants decommissioning projects in the future. One of the most important projects in closing the plant is the Interim Spent Fuel Storage Facility, B1. A complex system had to be designed, manufactured, and installed for safe loading, transportation, and storage of nuclear fuel from the reactors. The nuclear power plant throughout its operational time had used more than 21,500 fuel assemblies, 6,000 of which are stored in an old-style interim spent fuel storage facility. Yet a new interim spent fuel storage facility of the dry type is foreseen to store the remaining fuel. The capacity of the new facility is 202 casks. The planned number of casks to be stored is 190. The most difficult task is to design, install, and manufacture the technological equipment. New technologies will be needed for the safe defueling of pools and packing fuel rods into new casks for storage. The casks will be 4.5 meters in height, 2 meters in diameter, and 118 tons each. The casks will be moved by special transporter through a transportation corridor to a storage facility and stored for 50 years. Even if the storage period may be extended, Lithuania still has to find a final disposal site. Apart from the B1 project, solid radioactive waste management and storage facilities will be built. After the commissioning of the B2, 3, and 4 facilities, radioactive waste will be retrieved from temporary storage facilities. Very low-level radioactive waste will be transported to a new landfill facility, B19, where it will be monitored for another 100 years. Remaining waste will be transported to the waste management and storage facilities for resizing, compaction, and final incineration. Later, it will be packed to containers, disposed in the new storage facility, and stored for another 50 years. One more project is the near-surface repository for low and intermediate-level short-lived radioactive waste, B25. It is planned to construct the reinforced concrete repository, which will consist of several groups of sections designed for the final disposal of 100,000 cubic meters of treated radioactive waste. After its closure, the surveillance of the repository will be carried out for at least 300 years. All these projects are interdependent and important for a successful Ignalina nuclear power plant decommissioning. No one has ever completed the decommissioning of such a powerful reactor. The process has only been started. For example, the operation of the Fukushima nuclear power plant was suspended, not decommissioned. Only nuclear power plants built in Great Britain can be compared with Ignalina nuclear power plant. And they are facing the same issues. Some of their graphite reactors are shut down, some are still in operation.
Perpus mažesnių negu kad Ignalina, bet su grafitu.
As decommissioning works have already started, it has become clear that leaving this burden for future generations would be very irresponsible. The knowledge of the personnel is priceless now. They know perfectly how the plant was built. Accordingly, they will know the best how to dismantle it. This is a great advantage for our decommissioning project. Experienced specialists, qualified workers, unique equipment, and technological solutions. Everything is in one plant. The only challenge is increasing decommissioning costs. The reason, according to scientists, is objective. The initial works assessment was too optimistic. It was impossible to do accurate cost estimations. Based on Great Britain's experience, the price there increased even several times. But the work's implementation cannot be accelerated. It would be very simple to dismantle any building of this size. However, we are dealing with a nuclear facility. Each decommissioning step must be approved by the State Nuclear Power Safety Inspectorate, and only after all technical procedures are implemented can the dismantling works begin. The work at the plant site is not typical. Every step must be evaluated. Best dismantling methods found and radiation measurements performed. You can accurately cost the price only after starting the works. It can be certainly stated that construction of a nuclear power plant is much easier than its decommissioning, because the dismantling of complex and contaminated structures requires much more precaution. All of the radioactive parts will be stored in the vicinity of the plant. In order to prevent contaminated elements from release into the environment, it is important to pay attention and make investments to ensure area physical protection. News reports provide information about the works performed, the dismantling of the reactor, and about how our men work there. I cannot describe it all in detail. We trust people who work there, and we live safely in this town. The site of Ignalina nuclear power plant changes constantly. Old equipment is being dismantled. New waste storage facilities and repositories are being built. New transportation lines made. In a decade, the place will not look the same.
The
final goal of the decommissioning is to restore the area to its initial condition. Needless to say, it will not be the exact same site. The goal is to create a brownfield. It means that nuclear waste facilities and other buildings will remain on site. Buildings will be handed over to state institutions of Lithuania and may be used for other economic or commercial purposes. The remaining buildings will be demolished and the site restored, so if we meet after the decommissioning of the first RBMK nuclear power plant, here we will be able to enjoy the view of a restored site and a young forest.
Todėl, jei susitiksime po pilno jėgainės uždarymo, galėsime pasigrožėti rekultivuotą teritoriją ir beaugančių jaunų miškų.
Today, no one can tell how the youngest town in Lithuania will look in 50 or 100 years. Visaginas residents believe that even if nuclear vision vanishes, the town will remain. Visaginas can become a popular tourist attraction point. With its unique sights and the biggest lake in the country, Drukšė.